എക്സ്ട്രാ അവറും വരുന്നുണ്ട് മാനേജ് ചെയ്യും.
മനോഹരന്റെ പട്ടിയുടെ ഭയങ്കര
എന്റെ അടുത്തുനിന്നല്ല, അത് വേറെ.
അല്ല, വേറെ. ഓ, റഹ്മാൻ.
എനിക്കാണ് സുബിൻ പ്രകാശ്.
സുബിൻ. സുബിനോട് പറ പട്ടിയുടെ വായിക്കുന്ന കിട്ടുക.
സാർ ഞങ്ങളുടെ വീട്ടിലല്ല സാർ, അടുത്ത വീട്ടിലാണ്. സോറി സാർ, സോറി ഫോർ ദി ഡിസ്റ്റർബൻസ്.
അപ്പൊ സുബിനകത്തൊന്ന് മ്യൂട്ട് ചെയ്ത് നോക്കണേട്ടാ, ആവശ്യമുള്ള സമയത്ത് തുറന്നാൽ മതി.
ടീച്ചർ ആയിഷ ടീച്ചർ ജോയിൻ ചെയ്തല്ലോ. ടീച്ചർ ഡിസപ്പിയർ ചെയ്തു.
അതെ, ഓക്കെ.
യെസ്, മനോഹരൻ.
ആയിഷ, ഗുഡ് മോർണിംഗ്.
ഗുഡ് മോർണിംഗ്.
എന്തൊക്കെയുണ്ട്? യു ആർ ഇൻ ദി ഡിപ്പാർട്ട്മെന്റ് നൗ?
അല്ല, വീട്ടിലാണ്.
ഓക്കെ. ഇന്ന് പോയില്ല, ഡിപ്പാർട്ട്മെന്റ് പോയില്ല?
ഇല്ല, ഞാൻ ഈ ആഴ്ച പോകുന്നില്ല. മകൻ വന്നിട്ടുള്ള കാരണം ക്വാറന്റൈൻ.
മകനെ മറ്റേ 7 days ഇരിക്കണം വേണ്ടല്ലോ, ഇപ്പൊ അങ്ങനത്തെ ഒന്നുമില്ല.
7 days വേണം. 7 days കഴിഞ്ഞാൽ അവൻ പോകും.
ഓക്കെ. അപ്പൊ ഒന്ന് ദിനേശിനെ പറ്റിയില്ല. ദിനേശിന് ചെറിയ അസുഖങ്ങളുണ്ട്. ആയിഷ.
അതെ, പറഞ്ഞു.
മനോഹരനെ പെട്ടെന്ന് കിട്ടിയ ഇതാണ്. മനോഹരനെ കിട്ടിയത് വലിയ സന്തോഷമാണ് എനിക്ക്.
അതെ.
ഗോപി സാർ ജോയിൻ ചെയ്തു. ഗുഡ് മോർണിംഗ് സാർ.
ഗുഡ് മോർണിംഗ് ഗോപി സാർ.
ഗുഡ് മോർണിംഗ്. ഓക്കെ. ഐഷ, ഗുഡ് മോർണിംഗ്.
ഗുഡ് മോർണിംഗ് സർ.
ഗുഡ് മോർണിംഗ്.
Manoharan, sorry, Rahman.
Yes, sir.
You can start the program now. It is already 11.
Okay. Yes, we have to start. Good morning, all of you. And today we are on the 4th day of our 7-day national webinar series on Earth, Environment and Society. And today we are having an eminent speaker and resource person in geology, Dr. A.N. Manoharan, Associate Professor and Head of the Department, PG Department of Research in Geology, to Government College, Kasaragod. And he will talk on the topic Modern Trends in Geoinformatics, and he is being with us. I welcome you, sir, to this program. And I also welcome Dr. V.A. Aisha, Head of the Department, PG Department of Applied Geology, Ponnani MES College. I welcome you, ma'am, to this program. And I also welcome Dr. C. Srijit, Assistant Professor, PG Department of Applied Geology, Ponnani MES College. He's also a keynote speaker in our webinar series. I also welcome sir to this program. And I would like to invite Dr. Subin Prakash to introduce the speaker to the participants. Thank you.
Thank you, Roman sir. Good morning to one and all gathered here today for the 4th day of the national webinar series organized by the PG Department of Applied Geology, GEMS Arts and Science College. It is disheartening to inform you that the scheduled speaker of the day, Sri Dinesh AC, Director, Geological Survey of India, Mangalore, is hospitalized due to some health issues and hence couldn't join us. I take this opportunity to pray the Almighty for his speedy recovery and sending him all our love and prayers. And now coming to our duty, I am really glad to inform you that the today's section will be conducted by an eminent and multi-talented personality, Dr. A.N. Manoharan, Assistant Professor, Government College, Kasaragod. We know that words are few to express our gratitude to him for having to accept our request in short notice. Happy to have you a part of our webinar, sir. Accepting an invitation in such short notice and delivering a talk is not an easy task. Thank you so much for being understanding and cooperative, sir. Well, I am honored to introduce Dr. A.N. Manoharan, Assistant Professor and in charge of Head of the Department of Postgraduate Studies and Research in Geology, Government College, Kasaragod, hails from Karatka village in Kasaragod district. He did his BSc in Geology from Government College, Kasaragod, post-graduation in Marine Geology from Mangalore University in 1995. Dr. Manoharan completed his Doctor of Philosophy from Mysore University in the year 1999 under the guidance of Professor M. Balasubramanian. He qualified the prestigious National Eligibility Test and Graduate Aptitude Test in Engineering 1995. Dr. Manoharan also did his postgraduate diploma in Human Resource Management from Kerala University. He worked as geologist in Universal Limited, Doha, Qatar, and also senior resource scientist in TriCAD Geomatic Solution Private Limited and TriGeo Image System Private Limited in Hyderabad. He also worked as an assistant geologist in Directorate of Mining and Geology, Government of Kerala, Thiruvananthapuram, and assistant professor in geology in Department of Civil Engineering, College of Engineering, Trivandrum. He has presented many research papers in national and international seminars and published research articles in peer-reviewed journals. He served in many academic and professional bodies in his career. Let me welcome the enthusiastic, eminent, and multi-talented Dr. A.N. Manoharan, sir, for delivering the talk on recent trends in geoinformatics. Welcome, sir.
Thank you. Thank you, Subin Prakash, for a nice introduction. And good morning to Valashan sir, Gobi sir, Abdul Rahman, Subin Prakash, Srijit, and other 87 participants from various parts of country. So I got an opportunity with a short notice in your webinar series to speak on any interesting subject. Actually, I was in this field, I was using GIS from 1995 onwards. 1995, during my research itself, I was using some element of GIS in different initial software format, and I have used it for my thesis work and thesis data I have processed. And afterwards, I have commercially used. I used GIS for commercial purpose from 2000 onwards. So that time GIS was not this much developed, and afterwards many changes have happened in the GIS sector. Even the term GIS itself changed into geoinformatics, geomatics, and geospatial technologies. Many other terminology arose, and now knowingly or unknowingly, each and every person, ordinary person, also using GIS in one or other way. And most of the people are, many of the people are acting as data pooler. They are pulling the data to the system because they unknowingly or knowingly they are data creators. Using their smartphone, they are capturing data, location-wise data, and that will be added to the GIS system, web-based GIS system. So like this, this technology has developed a lot, and application is too much. Wherever the spatial data is in use, they are using the geoinformatics or GIS. Why we are very much interested in GIS and geoinformatics is most of our data, geoscience related or earth science related data, are all spatial data. Anything we deal, we can attribute to the coordinates, geographical coordinates. So those data.
Excuse me, sir. You are already presented your slide, sir.
No. I'm not start sharing the screen.
Okay, right, sir. Okay, sir.
I'm audible now?
Yes, sir. Yes.
You're audible.
Okay.
Continue,
Okay.
please.
So this with since we are in geoscience or earth science field, we have to deal with a lot of spatial data. So whatever data we are dealing can be attributed to the coordinate system, and that can be used and that can be processed. And the hectic field work which we were carrying out in the past, especially the Geological Survey of India officials are all they were doing hectic field work during those days to cover the entire area with different type of maps, geological, structural, and geochemical mapping and all. So that amount of work can be reduced with GIS and geoinformatic technology. So field awareness, field knowledge, and preparatory work for the field work can be done in the field itself, I mean, in the lab itself. And the data, whatever they have collected from the field, can be processed at a faster pace in the lab. At the same time, they can do their data processing in the field itself. That much it has grown. And 3-dimensional or 4-dimensional, 5-dimensional, 6-dimensional data and all can be incorporated. And more research is going on, type of data that can be incorporated into GIS system, geoinformatics system. So I'll share my screen and we'll start discussion with the slides. So I think the screen is visible, sir.
Yes, Manohar, visible. Okay, continue.
Okay. So all of you know that communication and convincing are more easy with graphic presentation. So far before the formation of the first letter, people were using the graphics, drawings to communicate with other people. So just for, I mean, even route type of map also they were using, how to travel from one place to other place. They have shown with the drawings. And so graphical representation is more easier and more communicable and more convincing. Mostly it is very appealing. Other people can see the graphical things with a lot of interest, and they can understand the graphical instructions easier than the written or report type instructions. So that is the beauty, and people are attracted in graphical type of instructions to deliver as well. People are interested to accept the graphical type of instructions. So that is the initial way of representing, starting of GIS. So here you can see two information. One, same data in a exhausting tabular form, and the same data can be seen as graphical representation. So what you will prefer? Normally we'll go for this map type because it is very easy to see and it is very appealing and very easy to understand, which are the geographical spread and which are the area with the specific information. So even if it is in a report form, written in pages and pages and paragraphs, nobody will be interested to go through it very thoroughly and read each and every line. And better than that, they will be preferred to see the maps. All administrator and planning people are all prefer to see the data in spatial representation in the form of maps. So that is the beauty. So that is the reason people prefer graphical data than the report or tabular data. Only in case where we need more information and more detail, tabular data can be used. And other interesting thing in GIS is this tabular data can be viewed through the graphical data. You can click on any feature, and at the back end of this feature, you will get this tabular data. You can view it and you can analyze. And another thing is these graphical data, these tabular data, if you want to represent in another form of graphical representation like a pie diagram or histogram diagram, that also possible. So now I was talking about the geographical information system without its definition, what it is and all, just to have an idea. Now let us see the definition of geographical information system. So geographical information system, or generally we know GIS in short term, is a computer system. It's a combination of software, hardware and all. There are programs, software programs and tools developed in the form of software. And this system, this hardware and software system is used to capture, store, manipulate, analyze, manage, and present all type of spatial geographical data. Here, the data input in GIS has got a speciality when compared with other data and other information system. Here, the data is geographically attributed to coordinate system. All geographic data or position data is represented in the form of coordinates, longitude, latitude. Any other coordinate system can be assigned and the data is attributed to that. So the system have a component of capturing data. So data can be captured with many tools. And in the initial stage, you know that we have to convert the physical form of data into digital, and then you have to take it to the software, into your GIS, then only you can start. But now, from the field itself, you can capture the data in the digital form and transfer from the field to the GIS system through wireless or wired network. And next thing is this data has to be stored in a proper format and it should be readable to a GIS system. So storing data has to be stored, and if any manipulation is required, anything if you want to change in the data, if you feel that there are some error in the data or something erroneous in the data that you can change, you can manipulate the data. Or if you get further data from the field, you can add it in the same data system. You need not make another copy and all, you can put it in the same data, so that will be updated. Then another beauty, very important aspect is analyze. You have to analyze the data for to give information. You are inputting data, you are getting information after analyzing the data input. So analysis tools every day, you are getting newer and newer tools to be added to the software to do the advanced level of analysis of this spatial data. Then after analysis, the best thing, other thing is you have to manage the data. How to manage the data? Sometimes the data will be huge, voluminous data base may be there in your GIS system. Sometimes the satellite image, continuous multi or temporal satellite image and will occupy a lot of data. And access to the users also may have to restrict it to a certain extent to see the safety of the data. And also you have to manage the data properly, and you have to have interoperability with other software system, and how to reduce the data while transferring from one person to other person or one institute to other institute, and how to extract the data once it is compressed. So all these things will come in the management of data. You have to manage it properly. And next is presentation. So the person who is expertised in GIS can understand the data in the GIS system itself, but you are providing this data, output data to the person. He may not be knowing the GIS and or the technical part he will not be knowing. He wants the data for his planning purpose. So you have to present the data in such a way that a common man or a planner, a person who is specialized in other field also has to understand the output. So you have to present data present the data in different format. Map, normally we give it in the form of map. Now you have different way. Either you can give a physical print out of a map, or you can make it into a soft copy, or you can just keep all these things in all the output in the form of a PPT presentation and present to the people, those who are interested in the output. Then different type of spatial representations. As I mentioned, the components are hardware, software, data. Data has got a speciality. They are geographically referenced to data. Then there are methods, the data processing methods. Finally, people, man, brain is required to process data, and the data users also required. One of the very important component is users. Without users, data creation is of no meaning. So next comes geoinformatics. So here an integration of many systems put together, we started calling it as geoinformatics. It is the science and technology which develops and uses information science infrastructure. So the information science infrastructure facilities are used to manage or address the problem of geography, cartography, geoscience, and related branches of science and engineering. So all these special related data can be integrated together with the help of information science technology. So different tools developed in the information technology is utilized for spatial data management, spatial data creation, management. So most of our data acquisition is through these technologies. I mean, information technology used to transfer the data and assimilating the data and creating a database. So when compared to 10 years ago, lot more change, quite a lot of change has happened in this field, especially in data acquisition, integration, and analysis. So acquiring data for a new GIS is no longer a major problem. So you have a lot many tools, and the tools will be automized. Many tools are automized. It can acquire the data and transfer the data to the GIS system, and the data can be acquired in the soft form itself. You need not convert. You need not go for digitization or converting the data into vector format and all. It is the old fashion. Now we can capture the data. As I mentioned, knowingly, unknowingly, each and every person is acting as a data capture. And they are capturing the data using their smartphone, and that data will be reached to the server, and that data can be used for many purposes. And GPS has become a major resource of new GIS data. So most of our GIS data are captured with the help of GPS tool. So data for the GIS, one of the very important source of GIS data is GPS, because most of the data, GIS data, spatial data are all should be geographically referenced. So the spatially referenced data can be captured using a GPS system or GPS receiver. So since your mobile phone also have the GPS receiver and application to manage the data, so you can easily capture the geographical position data, your position data, and the position data can be attributed with many other location-based information. So very easily you can acquire the data from the field. So this integrated GPS GIS system will help us to capture the data from the field. So that has eliminated the laborious process of data conversion into GIS. So digital map images such as scanned maps, air photos are used as a background image for crosswire registration and that. Even in your mobile, you can get the raster data, images or map from which you can extract the required data. You may not be required entire information what is there in the image or a map. You may have to extract some of the information for a specific project, only road or only the water bodies, only the rivers. So you can extract the required feature only, and you can keep your image or air photo as your backdrop, your data backdrop, and you can extract whatever you want. So such changes had happened. A lot of changes had happened in this last 10 years. So this diagram shows what sort of changes has happened, the past and present data. So when I was I have started my GIS work at Hyderabad. I was doing some of the project for NRSA and Andhra Pradesh Pollution Control Board and some other agencies, those who require the map and the spatial data. And that time, we were spending our maximum time, 70% of our time for converting the data from physical form to the digital form, digitization. So we will be putting a team for a continuous shift, two shift or three shift running, morning, evening, and even night. Some people, group of people will be working on converting the physical map into digital map. So they will digitize, they will vectorize. And initially, when I was doing my PhD research work, we were using a digitizing table, a digitizer, a pen. So using that pen will be moving over the features on the map, and simultaneously the feature will be converted into a digital vector feature. So that is a hectic and laborious process. Afterwards, that is discarded, that instruments are all now not in use at all, that digitizing table, digitizing pen and all. But now we have heads-on and digitization, on-screen digitization. You can keep your map as your backdrop and you can digitize. So like that, when I was starting this technology, digitization technology, with the help of on-screen digitizing or heads-up digitization process was there. So we put our topo sheets. Initially, we will scan the topo sheet and georeference the topo sheet and keep that topo sheet as backdrop. Then extract the features. So 75% of our effort and time we spend for data creation or data conversion. Then comes, you need not only the spatial data has to be attributed with a lot of tabular data and the field information and all. So attribute tagging, linking the attribute to the spatial data. So you have to type the data, put it in the Excel sheet, or you have to put it in the attribute table of the GIS layer. So that is 10 to 15% time or effort is spent for attributing the data to the feature. So that was the great work. Only 5% is spent for spatial analysis. So that data, sometimes people, client require only the map output or a map of a separate layer, but they need details. I remember that one hydrographic feature extraction project which we have done for the US Texas area, only they want the hydrographic features. Only the water bodies and drainage system has to be captured from the aerial photograph. So that work, even though we feel that it is very simple work, just digitizing the drainage network, but their specification is around the 300-page matter. So you have to be very careful where to start the digitization, where to end, start node, end node, and all specific instructions they have given. So that way, what they want is, there is no much analysis also. They want the output. Hydrographic features has to be captured, and that should be with a specific instruction, specific whatever specification they have given. According to that specification, they want the data. There is no much spatial analysis part in that. Only 5% is spatial analysis. We have to check the spatial issues and topology issues, and it has to be checked, and the vector head arrow has to be checked whether it is in the flow direction is correct or not. So that way we have to check the data, only very small amount of spatial analysis. But now you see the present day, the data conversion part is very small, say for just 5%. But attribute is okay, there is no much change because you need to have, there is no other way. Either you have to put it in an Excel table or CSV file or Oracle database. You need all this attributed data in the form of tabular form. So either you can manually attribute it or you have to convert it from source. So attribute tagging is, there is no much change. But spatial analysis has improved a lot of tools are available. So we'll be spending much of our project time for spatial analysis. So this is the change, that hierarchy is reversed. So you are giving more important to spatial analysis, less important to data conversion, because data is available in the public domain, or you can easily access the data. You can buy the data from different agencies, or even if you do the field survey, you can use the instrument which will capture the data very easily, and that will be in the form of digital data. So that easily you can incorporate it into your data system. So that part is managed well. Spatial analysis you have to, because your most of your, your application, spatial data application is continuously increasing, and your area of interest also increasing. So newer and new spatial analysis tools are incorporated into different softwares. So the spatial part is increased. So same thing is shown here. So initially we were playing with the static data, static map. Once you prepare the data, afterwards any change is there, that will be added to the map, and the data will be in a static form only. There is no dynamism in the data. There is no changing data or fuzzy things of data we are not incorporating. So we'll prepare the map or diagram and take the printout or given to the client, or if they want in a soft copy form, that we will be giving. So it will be in 2D data and static form. So, and it is scaled down to representation of the real things. Real things will be represented in a symbolic form. So, but now visualization and virtual reality, most of our information will be in a virtual reality form you need, so that your decision making will be very easy. Object-oriented GIS is emerged, so things will be in realistic form, and you can represent the features with a different symbol set or mathematical representation, numerical representation that can be used for analysis. Different type of calculation, raster calculation or vector calculation for the better output. Then a real-time display of phenomena. So real-time data generation and real-time data can be displayed. So for example, a forest fire, real-time forest fire can be analyzed using your GIS system. That video can be attributed as a table, attribute data. And when you click one place, what is happening there? So some phenomena you can show with animated or video, this one, or field photograph and even freeway traffic flow. Traffic flow can be animated and shown as a GIS database, and the changes that is happening every day or every moment can be represented. So that much development had happened in geoinformatics or GIS system. So web portals serve continuous sensor-derived data. Now, if further improvement, development happens in the GIS or our Earth observation system, we may get a continuous satellite image. So every change, what is happening on the Earth surface, we may be able to monitor. So days are not far to get such updated data, every moment data to a system. Only thing, the data handling will be still an issue. So here a map you can see at different time. This map is created based on the cell phone call, cell phone data, mobile data. Based on they have tracked the mobile phone when they are using, people are using, and they have plotted that data. You can see that this is the data in July 10, 2006 at Rome in Italy. So this is a population density data. The green colored area, the green shades shows the higher density of population. So how it is changing? You just see that 9:15. Sometime probably the office hours might have started. There is no much this particular place. So just to concentrate this particular area. So in 9:15, there is no much population. 4:30 slightly increased, and when 10:15, all people might have come back to this residential area. The population density is increased in this particular area by evening 10:50. So this is a dynamic type of map for population density. So the use of this map is you can plan your traffic. You will get a real-time traffic information, how people are migrating and where the traffic problem is there, or where more people are traveling, or where congestions are there, like that you can monitor. So even if you see your Google map for finding a location, you can see some patches are shown with road, some patch are shown with yellow color, some patch with a red color, and that will be changing time to time. So that shows the traffic density in the road. So you can plan, you will be selecting your target location and you are driving that road, and every time if you see the some patches are shown in red color, that means there are traffic jam in that particular portion. So you may be taking a bypass and another road to avoid this red part, and again reach to the main road. So like that, for planning your traffic system or traffic information and transportation planning, finding out the taxi cab location, like for such a purpose, we can use this sort of dynamic mapping, changing population density, or just tracking the travel of normal people from one place to other place. Just track only here, tracking the cell phone locations continuously, constantly. It is tracked by the network enable calls to receive station, and that will be plotted as a map. So there is a revolution happening in geographic science and technology. So this is science as well as technology. Many branches are integrated into together, and it is called as geoinformatics. In past days, we were dealing remote sensing separately, aerial photographs separately, photogrammetry separately, field survey separately, and LIDAR based data acquisition, LIDARs, microwave remote. It's a different branch of spatial science we were dealing. So now all those branches become input data for our geoinformatics. You are acquiring data with all those what I have mentioned. With using that tools, you will be acquiring, and it will be integrated to geoinformatics. So all these special technologies are put together under a single umbrella, and we have started calling it as geoinformatics. Plus this mathematical modeling, numerical modeling, analysis, and all together put it into this main branch, geoinformatics. So modern trends of GIS or geoinformatics: better understanding the spatial issues and spatial problems and spatial data, integrating the data into a system, and application and manipulation of GIS data with other field to develop new technology, software features, and all. So we are integrating the spatial data with many other information system or many other information, and you'll be getting an holistic output. So and newer and new tools are coming up to integrate this data. So that is the new trend that is happening, how to integrate the different source of data. The same problem we are facing, because many of our institutions, many of the agencies or institutions who are dealing with this spatial data have lot of information, spatial information is already generated, but the issue is sharing this data, and interoperability of the data is a problem, and bringing all the data into a common system or open source data is an issue that is still discussed, and the data are, many of our government institution data are staying as, just as islands of data in many places. So the recent trend is trying to integrate all these data available and develop a system to access the data by users. So our data dimension also increased. Dimension in geospatial data is increasing. Initially, we were using 2D maps, and 2D maps into 3D maps. You will be having vertical data, whether the depth or elevation also attributed to the coordinated data. So using that, this elevation data, now we are using this part of GIS tool for interpolating any type of data, any chemical data or water table data, concentration data, whatever it may be, rainfall data and all. We'll instead of elevation, we'll use that data and we'll interpolate the data and make a seamless mosaic. So you have a vertical dimension component, either elevation or depth also included in your geospatial data, and that can be represented as a virtual model. You will get you'll be seeing the feature as if you are seeing the from top of an area, and you can assign any color codings or any symbols. So here you can see data acquired using LiDAR, laser image. So you may be wondering, so all these data, this is power line, tower, and each iron bar of the tower, bridge structure and all captured very well. And all these are points, all n number of points, huge number of points which carrying longitude, latitude and elevation data. And it is rendered with different colors. Because every information you will get, means distance and its arrangement, and also this data represent it a miniature representation of the field feature as such. So with this you can plan a lot. So this data is known as point cloud, n number of points. This is not just an image, it is nothing but number of points, n number of points carrying longitude, latitude and elevation data, any other coordinate data. And of course some color rendering is given to understand the elevation difference. So now the recent trend is using unmanned aerial vehicle, drones or UAV. So you can mount the camera, and if you have the camera calibration parameters and the height information and all, you can very well georeference the image captured by unmanned aerial vehicle or drones. So easily you can cover your entire survey area within a short span of time without any risk. You will be operating the vehicle from a remote place, and the drones will carry the camera, and even if it is a LiDAR camera, it will capture the data in three-dimensional form. So very fast, within a short span of time, you can cover a large geographical area and acquire the data. And another beauty is now it is possible to integrate the data with the multimedia. So multimedia GIS allow to incorporate not only spatial, temporal, geographic information in image, and it also help you to add multimedia geographic information. Even you can add descriptive text to the attribute data, or scan the photograph of specific feature in an area, graphic, digital, sound, or images, or video clips can be added to your GIS system, or audio can be added, and images also can be added. So when you click on a particular location which you are interested in, you will get a video video including the speciality of that area, and audio also you get, image also get. So our attribution is changing a lot. Instead of tabular data, you can integrate all this image, audio, video, and also multimedia files, even animated files can be incorporated in the GIS system. And other thing, as I mentioned, instead of attribute tabular data, the tabular data can be represented in the form of graphical features like pie diagram, histogram, and all specific to that location. So this particular pie diagram represents the data pertaining to that particular location. So like that, wherever on the map you can create this pie chart or histogram and represent the tabular data into graphical data. Your basic spatial data is at the backdrop, and to the specific location, you will get the tabular data in the form of pie chart or histogram or any other type of line, graph, or whatever it may be. And even you can include the photograph of that particular area. So this will be much helpful in geotourism. Famous monuments of places or palace and all can be its photograph and its video, interior video and all can be incorporated in the map. And especially the many of our geological information also can be mapped or it can be captured in the form of video and incorporated in the map. So our field work, field task for students, especially during this time and all, students can access information. They can prepare map based on the information available on the open source data like this, photographs and images, if it is available of a particular area. But even though there are limitations, but to a certain extent, you can understand the field with the help of this sort of videograph, photograph, and other attribute data. So technology has evolved during the last few decades. It is growing faster rate both in hardware, software, and development, new hardware. So as I mentioned, when I was working in a TriCAD image system in 2000, and we had a project of Karimnagar forest area classification using satellite image, IRS-1B satellite image. From that, we have to classify the forest area into degrade forest or evergreen forest, like that categorization we have to make. So they have asked us to do it digital classification. There is no interpretation, visual interpretation and all, digital classification, controlled digital classification. So that time one image, sometimes it may 100 MB image and all. So what we will do, we had low in the system when compared to today. That time system capacity processor and all low end, and we were using a SAVE system, that is the fastest system available in that company. And we'll keep this, I mean, we'll prepare everything, georeferencing, whatever thing we can do with the minimum time and less time taking, what we will do till evening. And evening we will keep the image for classification. It runs for many hours because system is very slow and processor is slow, so it will take a lot of time. So night time it will be running, and morning when we come back to office, we'll get this classified image. Like that, very low end system. When at that time that was the high end system, high end processor, and we were using the huge data processing, and just will run the processing during the night and the morning. So like that, software capability tools was not much improved like this. Minimum tools only available in that PCR info and all, or even in Eradas at that time there was no much tools and all. And our hardware system also not that much capable to do advanced level of spatial analysis. So now things has changed. Using your laptop or using your mobile itself, you may be able to do some of your spatial analysis data. And we have a static and interactive atlas. You can modify the data which you are accessing. If you want to add some more data into the atlas, you can do it. So interactive atlas allowing user to manipulate the data sets. Even you can add the data, or if you feel that some of the changes is required with the permission of the provider, you can do that. And GS server are already providing software architecture to enable multi-user access, serving maps and data on the web. Some of the special activity you can do without software in your system at all. So the software, data provider provides tools for analyzing that data. So multi-user can access the data from the same server, which is kept somewhere. We will not know where the data is available. You are accessing data and you are accessing the software tools available along with that data for processing the data. So like that, being away from the source data, you can process the data, you can access what you want from the entire data set. You can use the tools and extract whatever data you want, you can use it. So like that, distributed GIS and distributed processing data will be available in different servers kept at a different part of the world, and processing tools or tools also available in different servers, and you can access both these tools as well as the data, and you can process it. Similarly, web-based maps and web services, web-based map, the data will be available through the web. You can access the data, and you can process the data, and if you want to for a specific purpose, you can extract from it. And the web services also available. So web map like Google Map and Google Earth. So if you want to extract, you can work on Google Earth. You can select by name or by giving the coordinate of the area of interest. So that part will be zoomed in the Google Earth. Then you can work. There are limited tools available in the Google Earth itself. You can create features, point or polygon features. You want some information from Google Earth, you can extract it. And if you want to capture some part of the Google Earth image, you can do that. And afterwards, you can georeference or georeferenced image itself. You can access if you have some tools. So Google Earth is a web application map which is widely used by researchers and common man's users. So Google Map and Google Earth you can access through tablet or your smartphone. And using the Google Map, you will get a driving direction, selecting destination where you want to go, and you can plan your family vacation, navigation through the city and self-driven system. And you can just keep your Google Map in front of your driving seat, and you can track. So then mobile, wireless, and location-aware devices are currently used for maps and location-based services. So you can public participation maps also can be created. You can give some task. People can use their mobile phone, and if they have some, if you provide some app, they can capture their location, and whatever information you want, you can ask them to capture from that particular place. That will be updated in your GIS system. So wireless communication will be helping us to acquire the data from various parts. And public participation mapping also can be carried. So location-based services, LBS. It's an information service accessible with the mobile devices through the mobile network and utilizing the ability to make use of geographical position of mobile device. This is what we have seen one map initially, the morning time, afternoon time, and night time. So they have used this location-based data or location-based services to create a database. So mobile devices such as smartphone and wireless communication technology facilitated the spread of LBS. So the location-based mapping, location-based servicing is improved because of this utilization of smartphones and various apps available in the smartphones. So services to identify location facilities, business, hospital, etc., and personal navigation. So if you want to go some places which is known to not known to you, so you can navigate by using the GPS-enabled smartphone, and you can use some of the apps. In travel direction, you will get audio direction. You will get and traffic information service, as I mentioned, if you use the Google Map, whether the area has got traffic density at a particular time interval, so that you can check and you can plan accordingly. If you want to shift, change your direction, you can go bypass road and reach to there, and you'll be getting weather services. So this monsoon season, I think almost all people download this Windy app and see whether any cyclone and other information you can get. Animated form of map is available. Continuous analysis is done, and the present condition is shown in that map. Then proximity services. So in a location, if you are staying in your, standing in a particular place, You want to know where ATM machine is available, where is the nearest restaurant, where is the nearest petrol bunk, or where is the shopping mall, and all you can search, because your position is known, and surrounding proximity, nearby area, what are the facilities available, you can check, and you'll be able to access it in a short span of time. So this technology behind location-based service is position. So here one of the important aspect is positioning, GPS positioning. Your position is referred with the help of coordinate in a longitude, latitude coordinate. So the most widely recognized system being a GPS. So all position is based on these satellites placed at the space. So GPS is widely used for location-based services. Of course, wireless communication technology, information technology, help wireless communication, Wi-Fi technology, or cellular network also facilitate the spread of location-based services. So now mapping is common man's practice, or data acquisition common man can do. And cloud computing. So this is another interesting thing. You need not bother about the space in your system and all. You can do the cloud computing. You can access a controlled access. You will get so on demand. You'll availability of computer system resources, spatial reference data, cloud storage, and computing power without direct active management by the user. So here you may not be required. I mean, a high-end system you may not require, and you may not need the spatial data. You can request to the system, and you will be provided. You will be accessed from the. You can do the cloud computing, and you will get the result. So cloud is a computing paradigm in enabling on-demand network access to a pool of computing resources, network servers, storage, application and services, even data you can access, and you can do the computing with their system available at that place and access it. And you will be knowing where exactly the server and where exactly which space you are using. So present the idea of distributed computing. So the location of the computer or server are in different places, location of the data also different places. So moving application services and data from local storage to a dispersed set of server and data centers. You need not keep entire data in your system, and you need not develop a GIS for exclusively to your project. You can access the information which is developed for different purpose and which is available at a various place. So cloud-based GIS or GeoCloud, we call it as GeoCloud, which is adopt cloud computing technology to provide GIS capabilities on the cloud computing system. So user can use a provider infrastructure and GIS capabilities. Someone else is the host. You are remotely accessing the server. So advantages is lower operational cost, quicker development times, and device independence. You need not worry about advanced instruments in your lab and all. You need not spend a lot of money for advanced hardware procurement. Enable heavy-duty data crunching to better process and explore internet information pools. You need not purchase heavy data into your system. You can access the required part only. Pay for usage reduces fixed expense and hardware, software maintenance. But only thing, you have to understand your requirement very well, and you have to ask the data, and you have to access this cloud system. Capabilities of data and processing is at the mercy of. So this is one advantage. You have to seek the mercy of other people. Data processing is at the mercy of the service provider and a reliable internet connection. You require a very good internet connection, fast and reliable internet connection. At the same time, the provider has to permit you to access the data and process the data. capability is limited by marketable demand, standardization and provider incentives. Then scrutiny concerns liability, legal position, and data processing ownership responsibilities. Such issues, some issues are there related to the accessing data accessibility and the liability, legal conditions, data restriction, and this is one best example of cloud computing or cloud data access is Google Earth. So it seamlessly bring together imagery from numerous data centers. Actually, Google Earth is not storing the entire globe satellite imaging in a one server or single place center. They are accessing from many data centers to their system that will be in the form of a globe image with many data, and the data are all in different place and different data centers. They have data from I think 1993 onwards. So they have a satellite image of various places, and you can search historical data, you will get different data. So all these data are not put in the same place. It is sort of cloud computing. It is distributed in many places, many centers. From there, they are accessing and putting into a system. And like this, ArcGIS Online provide cloud-based software and services, user storage, and access to GIS tools and imagery to the GIS community. So they even now their software license is not sold. We have to subscribe. Annually, you have to pay an amount and subscribe the software and utilize. Even data they are providing on subscription basis. You have to pay an amount, and instead of buying the entire software, you have to pay a subscription amount, and you'll get online service for that. So ArcGIS Online enable user to use diverse web resources offered by ESRI. Then another aspect, interesting development that had happened in the geoinformatics or GIS sector is crowdsourcing. So crowdsourcing is act of outsourcing the task traditionally performed by an employee or a contractor to an undefined large group of people or community, a crowd, through an open call. So you can just a participatory mapping, a type of participatory mapping. And many people, you can give the task to many people to access the data from various parts of the world, and that can be pooled into your system. So maps can be worked on by individuals and communities and crowdsourced, enabling them to place information on the base map. So you can create information, I mean, you can distribute the work to many people, even ordinary people can be given the data, so they will access the data and they will participate in your mapping work. So user generated content, UGC, is a content that have been contributed by the web user. So when you access the Google Earth image or Google Earth information, unknowingly you are providing information to that system, your location, and if you are in some location, that will be recorded in the Google search. So knowingly or unknowingly, the user also become a data provider to the system. User contribute to the geographic information describing to that particular place. So you are also becoming a volunteered geographic information provider. So VGI is a user geographic contribution of VGI is digital space data that is created voluntarily by citizen rather than by formal data producers. So you can contribute data to the system voluntarily. You can take up some part and you can do it. So Wikimedia and OpenStreetMap use web-based crowdsourcing technology, which outsources tasks to the crowd to collect the data. Then Open Geospatial Web Services, Open Data Systems, special geospatial web services are, and it continued to be the heart of WebGIS. So open geospatial web services. Data can be accessed freely and open source data are available. So a main base of cloud-based GIS is this open geospatial web services. So what is next? What is the future of geo information? So multi-dimension data will be added to the system. Similarly, some sort of fuzzy data. Still research is going on the fuzzy data. Fuzzy data means continuously changing data. So for example, our shoreline may change continuously. So how to accommodate such changing data into the system? So that has to be done. Future of GIS is in your hand. Those who are interested in GIS or geoinformatics can add more and more tools to it and more data to the system. Especially you can see the open source QGIS software. Every month they change it, or new tools will be added to the QGIS. So even you can create new tools and add to the QGIS. So every time when you download, its versions changed and more tools are available, or more plugins are available, which is developed in other open source software. So you can plug into that and you can do your data processing. So as a GIS analyst, you have the capability to use or misuse the power that GIS bring to the world problem. So the special data analysis, it is a double-edged weapon. You can use it and you can misuse also, especially the defense-related activity. And we may have our defense people are utilizing very advanced special technology to understand the movement of the enemy and what are the changes that are happening, especially our border and all changes. It is becoming a fuzzy boundary, or it's becoming a changing continuously. So a lot of changes happening in the boundary and all. So that has to be monitored continuously, and that has to be observed. Continuous observation system should be there. So a lot of application is there in the military field and all. So this is the last slide, and I have taken nearly 1 hour.
Thank you, sir. Thank you very much for your informative session.
Okay.
So, sir,
any doubts, if anything is there in the chat box?
Okay. Sir,
Please
there is
put
one
your question.
Okay, sir. There is one question.
Yeah.
So why can't you what are the key difference between spatial research data infrastructure and spatial data infrastructure?
I didn't get the question. What is the key difference
between spatial research data infrastructure and spatial
and spatial?
And what are the spatial difference between spatial research data infrastructure and spatial data infrastructure, sir?
There is no significant only thing. Spatial research data infrastructure means analysis part will be more. You have to do more analysis in it, and it will be used for your research activity. Whereas spatial data as such, user can use, and of course, actually I didn't get that question very clearly. What is the difference between spatial research infrastructure and spatial data?
Okay.
Is it?
Okay, sir. Sir, and there is another question, sir.
Okay.
What is the best place to easily access geoinformatics data from India?
Or Bhuvan site. Bhuvan site is having a lot of open source free data, and the GSI portal also you have data with regard to our Indian area. Bhuvan is the best that location from where you get a lot of satellite image and lot of thematic maps. Some of them are in the form of raster data only. You can take it and it can convert it. You can download that. Then USGS data, entire globe topographic data you have. Then like raster data, this what is there?
Okay, sir, is there any mode of payment in Goa once after?
And some agencies are providing data on payment, especially your NRSC data. If you want a data center, for specific data, they will charge. You can go to their website and check what is the price, and you can pay. And even they will access some foreign data and provide to you. Only thing you have to provide an order online. You can place your order, and you can check the details from their website.
Okay, sir. Then the next, I would like to invite Dr. Subin Prakash to deliver the vote of thanks.
Thank you, Rahman sir. It gives me an immense pleasure to deliver the vote of thanks to our well-versed personality, Dr. A.N. Manoharan, Assistant Professor, Government College, Kasaragod. First of all, I am really thankful to Dr. A.N. Manoharan sir for accepting our invitation in short notice and delivered a nice lecture on recent trends in geoinformatics. And we have learned a lot how the geoinformatics is very important in our modern life, and also geospatial technology and its evolution. Sir, it was a very nice lecture delivered by you. And sir, I believe that the successful of this program is purely because of support and guidance of the kind and good souls like you, sir. And I'm proudly taking this opportunity to thank Dr. A.N. Manoharan sir on behalf of PG Department of Geology, GEMS Arts and Science College.
Thank you, Subin.
Thank you, sir. I also extended my sincere thanks to all the distinguished invitees, teachers, and my dear students for attending the 4th day webinar. And before concluding our today's section, I request all the participants to show your interest in the entire section. Without your participation, it won't be a grand success. Once again, I thank you all for your attention. Thank you.
Thank you, Subin sir. Thank you. Today's session is concluded. Thank you.
Okay, thank you.
Thank you.
Dear participants, your certificate link is put in the chat box. Please go through for it.